Greetings everyone! Today we're going to take a look and explore natural logs. We've explored the type of log called a common log already. This is when our log has a base of 10, which is what our calculators use. So therefore that allows us to use the log button on our calculator. The new type of special log is called a natural log. It is a log with a base of e. We've used e, that is the irrational value, 2.7, as you know, and of course it keeps going as it is irrational. Now we abbreviate log base e as ln. It allows for calculations to be solved quicker and smoother, but they always mean log base e. So take a look at your calculator, as you do have an ln button to make this transition smooth. You'll want to have your handout that was provided to you in class to take notes on. I apologize that it was printed flipped, so this won't be the cover page, but that was the intention. Let's explore more of what a natural log is. A natural logarithm is a logarithm that has a base of e. It is the inverse of y equals e to the x. We know that because if I was to rewrite this in log form, the base becomes the base, the exponent becomes the answer, and what's remaining becomes the main number. So you can see that if I convert it, this log base e can be replaced with ln of y equals x. Just makes for a smoother transition. We're going to abbreviate it as ln. You'll see that button on your calculator is very close to your log button on your calculator. They put those together because they're directly related. You do not have to type in the base because the calculator already knows that it's log base e. We've worked with conversions before, going from log to exponential form. So just a quick refresher. An example could be if I had 2 to the x equals 10. I can convert that to log form. The base becomes the base, the exponent becomes the answer, and what's remaining becomes my main number. We can also reverse that. We could take a look at something with a log base 3 of 5 equals y. And I can convert that to exponential form. And I can say the base becomes the base, the answer becomes the exponent, what's remaining becomes the answer. You really want to get that pattern down as we're going to continue doing conversions, but now let's explore how to convert using ln. So we got to think of this just a tish differently. Think of, I keep saying the base becomes the base while we're writing an exponential form. But when I say base, I mean ln. So in this case, the base becomes e. So we're going to say ln becomes e. The answer still becomes your exponent. That step is the same. And what's remaining becomes your answer. ln becomes e. The answer becomes your exponent. What's remaining becomes your answer. Let's take a look at another one. ln becomes e. The answer becomes your exponent. What's remaining becomes your answer. I know this one's true because anything to the 0 power is always 1, no matter what. Let's go the opposite direction. E becomes ln. The answer becomes your main number. Your exponent becomes your answer. With this type of example, again, you can check your answer. You could type in ln of 54.6 into your calculator and you should get approximately 4. Let's take a look at one more. If I had, let's say, e to the 9th. Now it is approximate, but I'm going to round. E becomes ln. The exponent becomes the answer. What's remaining becomes your main number. Again, you can type this into your calculator. Now, because I rounded, it won't be exactly 9, but it'll be very obviously close to 9. So those conversions, take your time with thinking about ways to remember. ln becomes e becomes ln. The other two values are the same as when we did our conversions earlier with logs. Rewrite this natural log and then solve. So let's rewrite it first. E becomes ln. The exponent becomes the answer. What's remaining becomes your main number. In this case, we want to type that into our calculator and leave that ln value in your calculator. So I'm going to type in ln of 148.413. Leave it in your calculator. It looks like it's approximately 5. So if you're going to write anything down, you can write a 5 down, but leave it in your calculator. Then we know to get x by itself, of course, we've got to subtract that 1. So in your calculator, just press subtract 1. And what you'll see is 3.99999892797. It'll get kind of ridiculous. So we're going to round. We're going to say it's approximately 4. Here's what's great about these ones with numbers. You can check your answer. So let's do a quick check. If it's approximately 4, that means I have e to the 4 plus 1, which is the same as e to the 5th. If I type in e to the 5th into my calculator, I get approximately 148.413, which checks out. So I know that I got the right value. Let's look at a conversion to exponential form and then solve. So the first thing, ln becomes e. The answer becomes the exponent, and what's remaining becomes the answer. This one we can type again directly into our calculator, e to the 2.639. If you type that in, you get an x value of approximately 14, and if I was to round, it would be 0.00. Again, let's check our answer. I can check by typing in ln of 14 to see what I get. And when I type that in, I get approximately 2.639, which is a match, so I know I'm right. Use that calculator to make sure that that conversion is correct. Let's double check that we know how to type all of these into our calculator correctly. The nice thing about ln is most calculators put a parenthesis, so just make sure that you close that parenthesis after your ln value. Again, I keep saying ln, which stands for natural log. If we type in -2 ln 4, pause the video if you need to before you check your answer, you should get approximately -2.773. This next one, we want to simplify first. Always simplify what you can before you type it into your calculator. If I type in 3 ln of 6, I get approximately 5.375. For this next one, you're adding 1. So some of you might be more comfortable by typing in 4 ln of 6 equals and then add 1. It's up to you and what type of calculator you're using. So pause the video, try it out. You should get approximately 8.167. For this next one, notice that the +1 is not in parentheses, which means we are just taking the natural log of the 10. So be very careful. If your calculator gives you that first parenthesis, close it before you do the +1. Pause the video, try it out. You should get approximately 5.908. For this next one, you may want to do parentheses around each piece if you're going to type it all in at once. Try to keep it in your calculator so that you aren't rounding and using rounded answers. So 2 ln of 4, close parenthesis, plus 3 ln of 5, close parenthesis. Pause the video if you need to. You should get approximately 7.601. For this next one, again, you want to make sure that if your calculator gives you a parenthesis, you're closing it after the 4. Pause the video, try it out. You should get approximately 6.661. Okay? You want to make sure that you know how to type these in clearly no matter what device you're using. Again, if you don't have a graphing or a scientific calculator to work on these at home, you'll want to make sure to use an online tool or a calculator app, as your phone calculator will not allow you to use these parentheses very easily, and you typically won't get the correct answer. So take your time. For our next class, you'll want to make sure to have these notes completed. You'll also want to make sure that you have the log day 1 worksheet completed. We continued with log day 2 worksheet. We are going to grade these in class, so you need to make sure to have these completed and that you understand the steps of converting logs and using the real-world problems. We're going to work on natural logs in class after we grade these.